ultimately to provide clients with real business intelligence and decision-making ability. Vodacom is ready to be part of your digital journey. He is a business-focused technologist at heart with over 20 years of exposure to the full ISO stack, planning multiple geographies. In his current role, he is responsible for growing Vodacom's IoT business and adoption across the Western Cape, Central and Eastern Cape territories. He is a subject matter expert for the complete IoT ecosystem. He assists his clients with rapid digital transformation, including verticals like agriculture, medical, retail, manufacturing, and public sector. In his personal capacity, he is an IoT hobbyist, fully conversant from sensor design. Jeez, now I've got a couple of guys here. Okay, let's get that. Yes, thank God. Thank you so much. Thank you. Anyway, all the good things through all types of network connectivity: LoRa, RF, N-Blot, and Wi-Fi. All the way to platforms like ThinkWorks, IBM, Bluemix, Node-RED, etc. His experience spans across open to closed hardware software. In his off time, do you have off time?
Sometimes.
He's after hours, I don't know. In his off time, he does a fantastic job. He teaches electronics, robotics, and technology to kids, typically from unexposed environments, and hopefully to spark a maker renaissance. Ladies and gentlemen, Collin Mamdoo.
Sure. I think after all the exposure you've had to AI and robotics, I think the one key lesson that we've all learned is that if ever there's a robotic apocalypse, we need to get Shark's address. Shark, you need to share your full address. So I have the unfortunate pleasure of actually standing between yourselves and lunch, and typically that turns out to be quite a massive problem. And just back at UCT last week with Shark, I actually came across an interesting slide that I put up there. I think at this point in time, with all the exposure you've had, you are all now qualified data scientists, whether you know that or not. Any ideas what that actually means? To give you an idea, on the y-axis, we've got the proportion of favorable, whoops, that is my screensaver. The proportion of favorable decisions. This is basically based data taken from a typical court. You've got people coming in, having their cases heard, etc. And of course, a judge takes a decision at a certain point. And of course, in some cases, there would be a jury involved. So someone's gone and recorded all of this data. So obviously, on the y-axis, you've got the favorable responses being up there. And of course, the lower it's down, the more negative it is, or the possibility of it being negative. What do you think is on the x-axis? Any ideas? So who was it? Who was it? Oh, it was yourself? Well done. Okay, so you are now a certified data analyst. So exactly what that is, you've got lunch here, you've got a break at this particular point. What you actually find happening is that right before lunch, there's a higher possibility of you actually achieving a negative response or a decision. And straight after lunch, you've got the highest possibility of there being a favorable outcome. So if ever you find yourself standing in the queue, you know what to do. Okay, just hop into this. Sorry about that. We're going to just strictly transfer the audio.
There exists a connection between things, where all kinds of products, from cars and household appliances to industrial wind turbines and power plants, communicate about their status and usage in real time. A connection between things that tracks assets across the world and provides insight and information to help companies better service their customers. innovative ideas have led to new business models and product categories, where smart cities have the potential to help government in the private sector tackle society's biggest problems, including congestion, pollution, as well as crime. Where doctors can communicate remotely, so healthcare happens at home and not in a hospital. Where buildings and bridges, roads and railways are sensing and responding to changing events. Where communities tucked deep in the corners of our continent can communicate, work and thrive. A connection between things that is enabling industry leaders to bring their boldest ideas to life. Where smart services is enabling global companies to access Africa's ideas and people, allowing the continent to flourish. For more than 20 years, we've been delivering this connection to things, the Internet of Things, where our unmatched capabilities, experience, and global reach has been transforming lives and businesses in Africa with the power to do more. Vodacom, power to you.
That was the obligatory ad that I had to throw in there. And the rest of the discussion will be purely academic. So very quickly, we've all been talking about the Industrial Revolution, and we're currently on which iterants? First or second? Fourth, the fourth Industrial Revolution. I'm not going to talk about too much in this particular area, but suffice to say that for me personally, I think if you look at the first, the second, and the third Industrial Revolution, the one thing that was missing was Africa's participation. And the thing that I'm I'm really excited about is that in the fourth Industrial Revolution, Africa will now be a participant. And I think my call to action to yourselves as business leaders and technology leaders is take up the challenge, participate in the digital era, and be part of this new digital revolution. Just in terms of where we are right now, and I'm not sure if there are any nerds in the room, but this would excite you for a couple of reasons. Probably looks like a periodic table of elements. Number one. Number two, it's got a whole bunch of emerging technologies built into this. But very quickly to explain this, I'm not going to venture to go and describe every single bit of technology in this. But other than to tell you that this little green block on that side is described as Horizon 1. So I'm not sure if some of you may be aware of Horizon thinking, where Horizon 1 is business as it stands. It's the stuff that places bread on the table. In terms of Horizon 2 is what would happen in the next 5 to 10 odd years, and Horizon 3, what's coming up beyond that. So these specific emerging technologies have now been classified in those specific horizons, and as you can see, there is just no relinquishing. It's just coming at you in wave after wave after wave. Okay. So the question then to yourselves would be, where are you currently in your digital transformation? Are you capable of adopting a lot of these technologies when they eventually emerge? And how are you currently servicing your clients? But we're going to get to a little bit more on that just now. I think from an AI perspective, Dr. Ludik has covered this in deep detail. So I'm just going to continue to move past this. What I do, however, want to show you is a little demonstration in terms of what is it then can we use AI? How do we actually go ahead and implement AI today? Just a show of hands, who of you are using AI today? 1, 2, of course, Dr. Ludik, and 3. That's incorrect, right? All of you, 100% of you are currently utilizing AI. And you'll find it in things like, you've got phones on your desks, things, if it's an Apple device, you're utilizing Siri. Siri is based on AI and machine learning. If you are searching for something on Google, Google's built on AI and machine learning. If you are a Netflix user, you'll find that Netflix, if you type in a few of your interests, or just type in a movie name, Netflix will come up and recommend other movies that you would like. And it gives you a little number in the corner that either says 89 or 92 or 97. Any ideas what that number might be? It's actually it's a percentage in terms of a match based on the first movie that you decided to watch. The percentages basically say what is the possibility of you actually enjoying that movie. So I can assure that 100% of you are currently making use of AI and machine learning technologies, and this is not necessarily something of the future. So quick sort of way of example. This particular image, it's an AI model that was designed particularly in New York. There's a view out onto the street. I think it is New York. And very quickly, who would like to take a stab in terms of what's happening?
Sure.
Absolutely. So you could potentially look at the behavior of the drivers. But you know, quite evidently, it's now identifying what the model thinks it's seeing. Okay, so essentially we would call this computer vision. And you'll find that there's tons and tons of models out there that you can build code like this in about 10 lines of code. You can build this model today and actually implement it into your business. But of course you would need specialties like Cortex Logic, for example, to then go and further integrate that into your business. Any ideas in terms of what can you extract from this? How would you actually implement this? How could this be useful to a citizen? How could it be useful to the city of Cape Town? How could it be useful to potentially the security team, whether it's at a business or even the city of Cape Town? And I'll guarantee you that if I give each and every one of you a chance, you will each name a specific use case. Okay, but ultimately, something like this will basically help you count the number of cars. Right, so you see now and then the poor souls that have umbrellas and sitting at the corners of roads with little clipboards and a pen. They're counting. All right, I see 2 cars. All right, there's a van. Okay, there's a truck. And that's what they spend during their entire single day. Something like this tells you that is now obsolete. You can completely go and remove it today. Okay, so you can use this technology to start counting every single car. And what's really impressive about this as well is that we did not have to go and tell the system, all right, a white or a black sedan looks like this. It has these certain features, etc. Using the power of machine learning, we have actually trained a system. We have trained a robot. We've trained an algorithm to learn how to identify vehicles. And as you can see, it's not just vehicles, it's telling you what the current traffic light signal looks like, whether it's red or green, etc. But one thing I do want to mention, however, is a very quick takeaway for yourselves. If ever you are placed on the spot, you said, what is the difference between back in the days when we used to, I don't know if any of you play with Logo in school. You have a little turtle, and you tell the turtle to move forward 10, you tell the turtle to turn right, and you tell it to go 10 again. And we can basically program a little turtle to walk around this room, okay? So that was our artificial intelligence back in the day, right? So it involved a person writing some code, which involved a computer. And that basically output some type of data. The difference between that and machine learning today is that you now have lots of data, so things like big data, feeding into a computer system. And essentially, the computer system is running an AI or an ML type system, and the output of the ML system is a program. Okay, so you're throwing data into this box, okay, that's consuming the data, and it is then learning how to identify vehicles like this. Anybody knows of another machine that's existed since the beginning of mankind? It's been doing that and continues to do that today. A newborn baby, right? A newborn baby. That's exactly what the baby does. Remember, no child is born learning how to speak, right? These are things that they suddenly learn. No child is born learning how to drive. Okay, so but again, the formative years to me is really what's interesting, in that by placing a newborn child, in any of your families sitting around here, after about 3 years' time, the child will speak your language, speak your accent, and all the relative nuances within your specific families. We have now been able to replicate that in machines. particularly from the work of Dr. Ludick, etc., and other pioneers in the field. We have taken all of that work and we can now suddenly compress it into just 10 lines of code to suddenly create a learning thing, ultimately. To give you some sort of use case, we have been liaising with the City of Cape Town, particularly around, we're going through the drought at this point in time, and there was always talk about day zero. So what we've actually designed for that particular scenario, if ever we got there, is exactly a system like this, where we have built a complete standalone camera system that has built-in batteries, has built-in solar panel, it's got an onboard DVR, which DVR records what it sees ultimately. It has wireless connectivity, and you can place it and deploy it anywhere you choose. Right? So why is it so revolutionary? Number one, it can be installed and set up by anybody. Number two, it's fully mobile. You can drive it around to whichever part of the city you want it to be. And number three, it has built-in analytics and built-in AI. And what it does is that we do exactly this that you're seeing on the screen. Is that if ever we do get to a day zero scenario, we would then, the City of Cape Town would have the ability to count the number of people in that particular area. Either count the number of people in the area, or actually count queue lengths at each of the water dispensing systems. What does it do for you? Okay, if we then take that data and make it available onto a map, and we then say, everybody, you now have access to an online portal to look at the current utilization of every single distribution point, what does it do for you? You will quickly go look it up and say, okay, hang on a second, the one in our observatory is a bit too busy, let me rather take a drive out to Milton instead. Okay, so it gives you a real life benefit from that perspective. And those are some of the things that AI could potentially do for you. And if it does it for you, it's going to do it for your clients as well as your own businesses and stuff. This is a very, very cool map. It's basically a map. If ever you're interested and you'd like to understand where your businesses are today, right? If I were to ask you, are you an analog business? Are you an e-business? Or are you an autonomous business? It can very, very quickly help you understand where you are at this particular point. So very, very quick example, if we look at the entities. If you're a business currently dealing with people, okay, and nothing else, you don't have any systems in place, you don't have any payment systems or whatever, you can probably consider yourself an analog business, which I'm sure that none of you are here at this point in time. If you take, for example, here you've got business systems in place and you've got people involved, so depending on where the other sort of areas take you, you can decide where you sit from that perspective. Now it gets interesting from this point here. Now, how do you call yourself a digital business? So for example, you've at least got to have people, you've got to have business systems in place, and of course you've got to have things. Okay? And things could be anything. Things could be your vehicles, it could be your chairs, it could be your tables, but smart things, the things that have the capability of communicating back into the system. Okay? And only when you've got that in place can you then shift up to the top level here, which becomes an autonomous type of business. You then start to make some magic from that perspective. Now, and I'm actually going to give you an example in terms of how you actually create that magic. This is a very quick, shall I call it, model in terms of how to build an IoT system. So from my perspective, the outcome that I'd like from this talk is to educate yourselves, to teach you how to actually build an IoT system. Anyone can do that. Okay? And I'll show you how to do it very, very quickly. And these are basically the 4 different components that you're required to build an IoT system. And the second outcome is I'd like for you to leave having the ability to identify opportunities within your business that you could automate very, very easily. Okay, so starting very quickly, in any IoT system, it always starts with a sensor of some type. So To describe a sensor, all that a sensor does is that it converts the real world into the physical world. Right? So by way of example, you've got a temperature sensor, you've got smoke sensors here as well. The temperature sensors are actually built into the air conditioning, because currently you've got a sensor monitoring the room temperature, and at the same time it's feeding back to the controller of the air conditioning to manage and maintain that particular temperature. I'm going to give you one specific example of a type of sensor, and I'm going to give you 3 different use cases for it. Okay, so just to give you an idea of the absolute scale of what we're dealing with here. Okay, before I get to that, the other types of sensors that you get, can you name a few of them? Any ideas? Motion, absolutely. Yeah, that's your security systems. You've got the little PIR sensors in the corner, and it's able to pick up motion, etc. Any other sensors? GPS, absolutely. Location utilizes the GLONASS system as well. So you've got temperature, humidity, pressure, liquid flow, liquid level. We could literally spend a week trying to cover every single type of sensor. But the point is that today we can convert the real world into the virtual world very, very, very easily. And which is why it's one of the key drivers behind IoT, and as to why it is such a massive, massive component of life today as such. The other thing is that apart from us just having the technology to convert the real world into the real world into the virtual world, is number 2 is that the cost has substantially dropped. Okay, so as we continue to see greater and greater adoption, it is happening. There is no question about it. IoT is being adopted around the world at an exponential rate. You'll start to find the cost per unit start to exponentially drop as well. So that's why today it is such a massive, massive buzzword. So back to the little sensor and the use cases. Take for example, if I placed a pressure sensor on every single seat in this particular room. Okay? And what that pressure sensor will do for me is that if ever you sat on it, it will tell me that somebody's sitting on it. And if you sit up, it'll tell me that you're standing. Most of you have cars today that do that. Okay? Any ideas what that pressure sensor is used for? 100%, right? Your seatbelt. It checks if there is a weight on the seat, it assumes that it's probably a person. You've probably seen sometimes you've left your bag there, if you're carrying a very old laptop with lots of books in it, and it will register a weight, and your seatbelt light will continue to flash. It's telling you need to strap in that thing that's on the chair. Okay, so all of you already have experience with a pressure sensor. So in this type of environment, I could very easily measure the occupancy of this room. So if I ran this particular hotel or this conference center, I could provide statistics to the owner, just in terms of the daily use of this room. How utilized has it been? Has it been at 100%? Has it been at 50%? What that can do for me as an operator of this facility or a facilities manager, I could then go and make a recommendation that, excuse me, Mr. CIO or CFO, this room over any particular month is always 50% utilized. There's a problem. So what could we do? We could actually look at breaking up the room into 2 separate rooms and suddenly allow me more of an ability to earn revenue in a different room, rather than just make 100% use of the entire room, but use it 50% physically. Okay? If you look at it from a corporate perspective, a lot of you have issues with, you've got very limited boardrooms. From that perspective, how many of you actually know how utilized those rooms are? It's very, very difficult to get access to a boardroom. You always have a last-minute booking or a last-minute meeting, and a room is never, ever available. So again, you could use these pressure sensors to quickly tell you how utilized your room has been, and whether you should split up your room, whether you might even identify a popular room. The room might be popular because it's VC enabled, or it might have a nice view of the golf course, or for whatever other reason. So suddenly, additional business insight has been unlocked. And all from a little pressure sensor. Okay, the other use case that you can make use of is, if you look at a contact sensor environment, and again, how many of you know that do operate contact centers, how productive are your people? And particularly if it's an outsourced component, how productive is this particular business in providing that type of service? And here again, I'm making the assumption that productivity is directly linked to somebody sitting on a chair. Okay, so again, you can then look at a contact center, pressure sensors, and at the end of a week, tell your client how productive their people have been from 8 in the morning till 5 in the afternoon. Okay, so that's sort of a negative sort of look at pressure sensing. On the positive side, if you were someone like Discovery Health, or if you were probably part of the HR team, and you want to promote employee well-being, okay, I could then look at Jacques. How often is Jacques actually sitting at his desk? And if Jacques is spending more than 2 hours in front of his screen, I could then automatically go switch off the monitor and send him a text and say, Jacques, you're sitting for too long, go take a walk. And we're not going to switch your screen back on again until you should return. So, you can start to suddenly promote something like that. Okay, so again, just by using a single sensor, we've described and unlocked 3 different use cases for it. And I promise you, we can probably spend the rest of the day identifying more use cases just from a pressure sensor. Imagine then you can do with every other type of sensor. Okay, so that will sort of give you an idea in terms of the sheer size of what we're dealing with. So in terms of building, let's say you have to go out and build the system in your organization. Whether you wanted to check the productivity of people, or whether you wanted to manage the well-being of your people, you can decide, be popular or not. But you would start off with the sensors. Now, typically in a room like this, we'll deploy a sensor on every single chair. I would need to then provide some type of connectivity to that sensor. Now, as much as I'd love to stick in a SIM card into every single chair, I'm not going to do that. It doesn't make financial sense. But if I do happen to do that, I'm going to go to Comms Cloud to help us with the device management from that perspective, because it's going to be quite a few different SIM cards to deal with. The thing that I would do, however, is that I could use multiple sensors like this that could talk to a single gateway instead. And on the single gateway inside the room, stick in a single SIM card. Okay? But from a connectivity, we are not just limited to just GSM. We can utilize any other connectivity type of medium available. The one thing you're going to start to see, particularly in the world of IoT, is that you're going to start to find competitors working together. You're going to start to find different types of suppliers working together, and that's what I love about this new space that we're in. Okay, collaboration has to happen across the base entirely. So the view that we're taking as well is more of an agnostic type of view. So we don't care whatever type of connectivity option you utilize, or from which other vendor you'd like to utilize. We just would like to enable the technology. Okay, so essentially you now have your connectivity element. Remember also that we include things like satellite connectivity. So for example, we've got a client that's up in the Drakenstein Mountains, and he's trying to measure the level of a dam that's right at the top, which is feeding into a river down to a reservoir at the bottom. And he wants to measure things like the current levels in the dam at the top. At that particular location, there's absolutely no connectivity. There's no mobile coverage whatsoever. So we would actually have gone and deployed a satellite dish. So again, it depends on the different type of use case or the different type of implementation. You could go and select any type of connection option that makes sense. And then from a platform perspective, again, there are quite a few different types of platforms. Some of you may already have a platform available which you can plug into the system and make use of. Or you can utilize a platform that we've also got available from that perspective. But why do you need a platform? It's essentially a single repository that starts to collect data. So again, using the pressure sensors from all the various chairs, etc. This platform starts to collect all the data that the chairs are basically setting up into the platform. And remember that all the chairs are doing is saying somebody's sitting on me and this is the time, somebody's standing and this is the time. That is all that particular chair is doing for the entire day. So if you take that and you multiply by the number of chairs and you multiply by the number of rooms, etc., you would actually have quite a bit of data. Okay? So you need some type of central platform that collects and accesses the repository. The second thing you could do with a platform is basically present the data back. So again, you're sitting at an exco meeting and you want to show your execs around the table, this is our current utilization of the rooms in the building. Again, your platform gives you the capability of presenting the data back and in real time. So you're not necessarily collecting and batching data as such. What you're doing is that you're looking at data in real time. Okay? The third thing that you can do with your platform is the ability to report. Okay, so at the end of the financial year, you want to now quickly produce a very quick document that talks about per month what my utilization has been, etc. The fourth thing you can do with the platform is the ability to act on something. So I'm not too sure if any of you have used an app on your phone called Ifttt. It's if this then that. If you haven't used it, I suggest that you actually download it. It's free, and you play with it. And you can do things like this. For example, if your kid has a mobile phone and they happen to walk into a particular GPS location, send a text alert to mom. Or if they happen to walk out of a particular GPS location, send an alert to dad. Whatever you want to do with it. So that entire ecosystem has grown to a point where you've got things like, if I happen to walk into a room, again at a particular GPS location, switch on the lights. So you can start to create a whole bunch of if this, then that. If the temperature using a Nest device shows a value of less than, well actually greater than 20, then switch on the air conditioning. Okay, so you can very, very quickly get into home automation by apps that are currently and readily available as well. And there's lots and lots of apps like that currently out on the market. And which is what this fourth layer here really, really talks about. From an enterprise perspective, this particular platform, I think Jacques mentioned that earlier on as well, is that you need to have an API capability. And all that an API enables your business to do is that it's got the capability of connecting into other systems. Okay? So for example, this chair sensing application that you all now know how to build, you want to plug that into the payroll system. Okay? So if anybody sits for less than 8 hours per day, you'll probably dock, I don't know, 10 or 20% off their salaries if they're terrible people. But it's got the capability of doing that, right? So you take all of this data, you then create an API link into the payroll system, and you've got that happening instantly. Okay? So can you just imagine the different combinations and permutations that you could do with something like that? If you, we heard the word predictive maintenance spoken about throughout the entire morning. Let's say, for example, you've got sensors and telemetry devices on a tractor that suddenly predicts that the alternator is about to blow up. It's about to go next week. The system can then plug into an API into some other third-party supplier and create an automated purchase order to say, if you know that thing takes 2 weeks to get to you, you can preempt that and say, I think that at the end of those 2 weeks, the alternator is going to pack up, and therefore here's a purchase order to order the device, the part, whatever, and have it delivered to my particular farm. Okay, and that is where things are currently going. And again, it's not necessarily something of the future. It is happening today. So maybe to speak a little close up on this here is that you've got your application layers, right? So ultimately, you want the ability to collect data. You need to provide some ability to connect. You then need to have the ability to analyze all of the data. And the fourth thing is you need to be able to action. Okay, so those are basically the 4 elements of any IoT system. It's collect, connect, analyze, and act. if you just go back home today with just those 4 words, I'd be over the moon. Okay, so that would actually present you as IoT specialists yourselves. Okay. So just in terms of the different types of use cases for the things, we spoke about the different types of sensors out there, and we spoke about different types of control mechanisms, etc. And this gives you a very, very quick idea. What we're currently doing for looking at water metering there by way of example, we're helping quite a few municipalities manage their cash flow. How do we do that? Currently, quite a few of them have been approached by Eskom with a terrible red letter that said, you guys have not paid your bills in the last 6 months, and we are currently disconnecting you. You all would have seen that in the media, where it's been a massive, massive problem. So what we then did is that we designed a completely bespoke system. We looked at things like the meters, the smart meters themselves. We then looked at the installation of those meters. Okay, so what we do there is that Vodacom does not go and install the meters, but we went to that specific municipality. We approached a learning institute and we said, give us 10 to 15 of your engineers that have graduated. There is a particular educational level required. We then engaged with a SETA accredited training agency. Said, can you train these guys in terms of how to install and support this particular smart meter? And by the time they actually left the training, they left with an NQF level 3 or 4 certificate. Okay, so then what we've noticed is that if you want big adoption from an IT perspective, go and make a socio-economic impact. And that's exactly what we've done with a lot of those municipalities. So we started to affect the lives of the people that live in that particular area. So we got the meters, we got the people to install it, we got the connectivity sorted out. We then looked at, from a metering perspective as well, as most of you suspect, the meter readings that you typically see and the bills that you get from Eskom, we've always picked up some type of discrepancy. The way we did that is that for the municipality that typically buys electricity for a suburb, at one point they're buying the electricity from Eskom. Eskom have their own meters installed, and then Eskom presents the bill to the municipality. So we actually went and we placed another meter, one of our meters, in parallel to that entire system. And almost every single one was incorrect. So we helped look at correctly metering Eskom and utilization. The second thing that the meters do for you is that in every single suburb we placed another downstream sort of meter that looked at things like it started calculating or measuring the amount of current utilization in a particular area. It then looked at all the endpoints in that area and it compared the two. And what do you think we discovered when we looked at that? Okay, in some cases you actually found that the check meter that was going into the suburb was far higher or a greater value reading when compared to the sum of all the other endpoints. And that immediately tells you there's theft happening, right? Or alternatively known as Izinyoka. Right, so you've got guys that were basically, say again? Izinyoka. It's a term that Eskom used to utilize. It actually means snake, somebody that goes and steals electricity. So we basically found that you can very quickly identify where electricity was being stolen. So if you look at that entire system, we basically engage with municipalities that were typically losing on average about 2 million rands a month, which is why they were being disconnected ultimately. Post our engagement with them, they swung around to black, and it went up to 500,000 rand per month. Okay, so it was a really, and we've also made a massive socio-economic impact in a particular area. And the great thing about these types of solutions as well, that we can package it as a cell phone contract that we can actually take it to the municipality. So we presented the municipality with very, very simple costs. There weren't any variable costs associated with it. It was a fixed, deterministic price at the end of the month. And of course, when it came to the price per unit, it wasn't even a discussion. I mean, if somebody comes up to you and say, we're going to swing you from the red to 2 million to black $500,000. There is no discussion around the cost of the individual buildings. Okay, so it's all about really going out and solving problems from that perspective. There's a whole range of other use cases here. Parking monitoring, for example, you can go and deploy sensors inside a parkade. How wonderful would it be when the day arrives you can drive into Cavendish, although they currently do have sensors that tell you that the cars are parked there or not and how many are available. It'll be great to then take that to the next level, and when you typed in Google Maps pointed you to the right entrance to utilize, where it thought that more parking was available, and as you entered, it then directs you to the first available parking spot through use of LED lights on the road as well. That technology is available. It is currently available, definitely across like some smiles coming. Definitely a Cavendish user. So ultimately, what is this smart bins? It's technology that's rolled out in the Netherlands as we speak. And why would you want to have a smart bin? Well, it's just really a bin. But that actually helps the guys that collect the trash. Okay, so if you now have a level sensor inside each of these bins telling you what the levels are in each of these bins, number one, and number two, which bins have actually been placed out for collection, and you take all of that data and push it up into some type of platform with some great AI and ML logic behind it, the ML system will then tell the pickup team, this is your GPS route that you need to take. Right? So every single time that they go out to pick up the bins, it's a completely new route that was prescribed by the AI system ultimately. Okay? And again, I mean that's been in place for 4 years already. So again, it's nothing new from that perspective. And yeah, there's a whole range of stuff. In terms of time, how am I? 2 minutes. 2 minutes. Wow. I'm just going to quickly skip. So I think maybe with my last 2 minutes, what I do want to tell you is that we've spoken about a whole bunch of different Lego bricks. Okay, Lego bricks in terms of different types of sensors available, different types of connectivity options, different types of partners out there, an ecosystem that can plug into this complete solution. There really is quite a bit, right? But we don't want to go and talk to our clients around technology. Basically, clients have a problem. Right? It's a problem that needs to be solved. What is your problem, Mr. Client? I haven't been paying my bills for the last couple of months. Can you help me? What is your client? Well, our pickup trucks for the bins are costing us too much. They end up picking up empty bins ultimately. Whatever the problem statement is, there is a solution. Okay, so I mean, this slide basically tells you, do not go and talk. And even at your executive layer type discussion, don't bother talking about technology. Go and talk about the guy that wants to have this fantastic experience about jumping onto a skateboard and whizzing down the road and doing whatever he does on that skateboard and the joy that he feels from doing that. Right? Sell the experience, sell the elation that you could potentially get from this particular project. I promise you, your IT projects or your IT implementation will be that much more better. I'm going to skip all of this. So that's me, I hope. If you've got a QR scanner, feel free to scan that. You'll have my details as well. But yeah, available for the rest of the day to engage. Are there any quick questions?
But just interesting sake, have they, and I'm sure they have, have they from monitoring someone on a camera or voice, have they gone as far with behavioral things from a security perspective?
Oh, you would not believe the advancement that have been made from that perspective. So that camera system as well that I showed you initially, you can also use it to create a virtual perimeter, virtual security. So let's say, for example, it's deployed out in the middle of a ground or a golf course like this, and you want to protect a particular area. Bring up that system, you draw a virtual line, and you say, if anybody crosses the line, based on the images that the cameras are picking, trigger an alert, or switch on the lights, or inform the greens manager or whatever it is that you want. That's the one thing that you can do. Then from the other video analytics as well, I think there's a great opportunity to look at to solve bullying in Cape Town. So each one of my kids go to a different school, and every single one of those schools, we have a problem with bullying. Okay? So what you can now do is with these types of cameras, you can monitor a school ground and start to count the number of people. So firstly, are the kids supposed to be in a particular area? If they do cross into an area, contact the headmaster or whomever else. The second thing that you can then do is count the number of people density in a particular area. As some of you may know, if you were really bullied at school, whenever there's a fight, there's a lot of people coming around to watch what's going on and who gets beaten up. Okay, so you suddenly find that people density grows. So the system can be programmed to say, well, if people density grows beyond 10 per square meter, whatever that is, there's potentially a bullying issue happening. Now, taking the same system and apply it to what's happening metro rail train stations, for example, we can then look at riot control. We can give you an idea in terms of when we think that there's potentially a riot that's about to break up in a particular area. Again, by just merely counting the number of people. We could go on.
Also from a facial expression or a tone of voice.
Oh wow, yeah. So again, it's currently available where you can do things like sentiment analysis, right? So for example, we could put a camera system here, looking at all of you, and the system can be trained. If most of you are like, that's a terrible presentation, right? And it'll flag red and it'll ask me to get off. Or if you are smiling, it's a very, very different thing. So we can actually quickly determine, and there's a specific area from this perspective called sentiment analysis. And we can tell you what the general sentiment was in a room, at a conference, in a school classroom type setting, whatever it might be. You can also do sentiment analysis not just from facial recognition, but you can do things, we can plug into the social networks. And today, we can very quickly build a model that will say, show me all tweets relating to Donald Trump. Okay? And the model will then quickly tell you, right, what does the sentiment look like in America? What does the sentiment look like in Britain? What does the sentiment look like in Russia? Obviously, far higher in Russia. You know, so you can plug into a whole range of other social media type systems. Obviously, those systems are API based. We can plug directly into them. We can read data, etc. And that is ultimately the magic of going digital. That's it. Okay.
Good. Thank you. Okay, guys, that's it. Let's have lunch. We'll see you back at 2. Step outside and do that. Thanks.
I'm not into IT long enough.